Well, hi everyone. Let's take a look at this practice test and see what we can do. First question, show that f of x equals 3 minus 4x and g of x equals 3x minus 4 are inverse functions, both algebraically and graphically. Explain why each method is evidence that f of x and g of x are inverses. Alright, so algebraically, I'm going to use this approach. If f of g of x is equal to g of f of x, and that is they're both equal to x, then that implies that f and g are inverse functions. Okay, well, let's find f of g of x. F of 3 minus x over 4 equals 3 minus 4 times 3 minus x over 4. 4's cancel. That's 3 minus x, which is 3 minus 3, and double negative is plus x. That's 0. So that's x. So we're halfway there. G of f of x. That's g of 3 minus 4x, which is 3 minus 3 minus 4x. Those parentheses are kind of important there. Over 4. Let me simplify the numerator here. 3, or just get rid of the parentheses. 3 minus 3 plus 4x over 4. 3 minus 3 is 0. So we're looking at 4x over 4, which is x. If f of g of x is equal to g of f of x, and they're both equal to x, then f and g are functions. So, inverse functions. F, circle that. I already stated that, and I showed it here. Alright, well, let's look at a graph of each of those. Now, this is a linear function, so is that one. But the y-intercept is 3, and the slope is negative 1. Negative 4, I mean. 1, 2, 3, 4, 1. Go down 4 and over 1. 1, 2, 3, 4, over 1. 1, 2, 3, 4, and over 1. Being careful how I graph. Up 4 and over 1. Let's see. Right there. Alright. Kind of careful. Alright. That is... This is f of x. Now g of x... I'm gonna actually just make a table for g of x. Let's go negative 2, negative 1, 0, 1, and 2. Let's change colors here for this. This is x, and this is g of x. So 3 minus negative 2 is 5. This is 5/4. 3 minus negative 1 is 4. 4 divided by 4 is 1. 3 minus 0, that's 3/4. 3 minus 1 is 2. 2/4 is 1/2. This is 1/4. Okay. So I've got negative 2 5/4, which is 1 1/4. Negative 1, 1. I've got 0 3/4, just right there. 1 1/2. 2 1/4. I put 3 in, that's 3 minus 3 is 0. And I got 1, 1, 2, 3, 4. I'm going to do that again. Go down 1, go over 1, 2, 3, 4. I'll go up 1 from here and go 1, 2, 3, 4. Just right on easier lines there. Okay, well now how do we tell, and I don't know if you recall, if we were to graph y equals x, and that's just splitting the first quadrant right in half and the third quadrant right in half, just following those diagonals of each of those squares, like right there. This is y equals x. And if you'll look, I think that the two are really symmetric. So I'm going to write that. The graphs of f and g are symmetric about y equals x, the line y equals x. Okay? That means, that implies there that f and g are inverses. Okay. Number 2, now we find the inverse, and I don't know, the technique, you put y for f of x equals 1/2 x minus 5, and then you do a switcheroo here. And x equals 1/2 y minus 5, and then you solve. After your switcheroo, solve for y. So I'll add 5, and I'll add 5. I've got x plus 5 equals 1/2 y. And you could divide by half. I would prefer to multiply both sides by 2. So 2 times x plus 5 is equal to y. You could leave it like that. You could distribute if you want. All right. 3. Let's do the same thing. Y equals the square root of x minus 10. Switch-a-roo. X equals the square root of y minus 10. Get y by itself. Solve for y. Square both sides first. Get rid of the square root first. That's x squared. It's y minus 10. And then add 10. I'm going to write over here. Y equals x squared plus 10. Alright, I didn't finish either one of these like I should, so let me do that right now. I want to write the inverse function notation. Inverse function of f of x is 2x plus 10. Inverse function of g is x squared plus 10. Alright, one more. Y equals 4x cubed minus 11. So let's add 11 to both sides. And I got y plus 11 equals 4x cubed. Let's divide by 4. And okay, reboot. Okay, I didn't switch. X equals 4y cubed minus 11. Okay, let's do that first. Now let's solve for y. Still going to add 11. I got x plus 11 equals 4y cubed. I'll divide by 4. And I have x plus 11 over 4 equals y cubed. To undo the y to the third power, I'm going to take the cube root. And that's giving me y equals the cube root of x plus 11 over 4, which I'm going to write as the inverse function of h of x equals cube root of x plus 11 over 4. Oh, nothing on that side. All right. Now we get to have some fun with a line of best fit. The following order pairs give the entrance exam scores X and the grade point averages Y after 1 year of college for 10 students. Okay, I'm going to make this the entrance. We got to make a scatter plot. Exam scores. What kind of variation do I have in this? 75, 82, 90, 65, 65 to 9, 65 to 93. Okay. Let's see. 2, 4, 6, 8, 10, 70, 8. If I go by 2s from 60, 2, 4, 6, 8, 70, 2, 4, 6, 8, 80, 2, 4, 6, 8, 9. Yeah, that's good. So I'm going to go 60 here. I'll start with 60. And then I won't write every, I'm going by 2s. This is 62, 64. I'll write every other one. That should be 68. 72, 76, 80, 84, 88, 92, 96, 100. Alright, I like to try to make it fit fairly nicely. Okay, now grade point averages 2, 3, 9, 2 to 3, 9. We can go 2, 2.0, and then 1, 2. I think this will work. 2.2, 2.4. Each one's a tenth. 2.6, 2.8. So you make a decision on scaling that fits the graph pretty well, the grid that you're given. I like to fill it up as much as I can. Alright, now it's time to plot points. 75. This is 74. So 75 and 2.3 is right there. 82 and 3 is right there. 90 and 3.6. 65 and 2, right there. 71 and 2.1. Oops, a little higher. 71, 2.1, 88 and 3.5. 93 and 3.9. 69 right there and 2.0. 80 2.8. 85 3.3. Okay. Now, describe the relationship between the entrance score and freshman GPA. This looks like a pretty strong. The higher the entrance score, the higher the... And, I don't know, you got this point here. This one looks kind of like an outlier, but it looks like a pretty linear relationship. So I'm going to go, there's a strong linear. I do think this is an outlier because it doesn't fit that line as well. Positive relationship. Positive meaning as entrance exams go up, that the GPA, which I didn't label that. Okay. Well, it is time to get into our scatter plot. So that means we hit Stat. You need to practice this and edit. I've got things in L1. I'm going to, so I went over and put it to the top. I'll hit Clear, and then I'll hit Enter, and it clears it out. I'll hit Clear here, and I'll hit Enter, and I will put these in. 75. I'll put the first coordinates in. 82, 90, 65, 71, 88, 93, 69, 80, 85. And then the corresponding with 75 goes 2.3, with 82 goes 3.0, with 90 goes 3.6, with 65 goes 2.0, with 71 goes 2.1, with 88 goes 3.5, with 93 you get 3.9, with 69 you get 2.0, with 80 you get 2.8, and with 85 you get 3.3. All right. We may as well look at this. If you'll look, let's go, 60 to 100. Just kind of like we did here, by tens, I'll just say. We didn't do that, but that's all right. Y min, let's go 2 to 4, and we'll go by 0.1s. Look at the graph. All right. Let me get that one out of there. I got a little ahead of myself. I didn't turn the stat plot on. And L1 and L2, so this is set up the way we want it. There we go. Okay. Now, it is time to go to Stat. Like I said, study this. Go to Calc, I want to get the linear regression line. That's what we're going to use. And some of you have prompts where you put in L1 and L2. I don't think I really have to because it's the only two lists I have, but I'm going to go ahead and hit second and L1. That's this button right here, the second and 1. The comma is right here, comma, second and L2. Hit enter. Okay, the least squares regression line. I've got y equals 0.074 x minus 3.084. Okay. Y is the GPA after the first year of school, and X is the exam score. So we have given the exam score, we have a prediction for what the freshman GPA would be. Doesn't mean it will be absolutely 100% correct. It's just a prediction. I'm going to write that equation in. 0.074x there minus 3.084. I'll just draw that graph, and you can see how that line goes through those points pretty nicely. It follows the trend of that scatter plot. Now we have to plop that on there. We've got this in here. I'm going to use a different color. I'm going to use green here. And I'm going to look at the table. Okay. I'm just going to put a couple points in. I want to put in for 2. No, wait. Okay. I'm confused. This is not the GPA here. This is the GPA, and it's negative here, so it's kind of outside of its element there. Now it scrolls pretty fast, so we can do that. You can also change your table set. Get that. Alright, I'm starting to see some things now here. 60. Let's go to where we're above 3. I'm going to put a couple points down and then draw a line through them. So at 70, I've got basically 2.1. 70 is 2.1. 70. Right here is a point on the least squares regression line. Let's go to 80. 80 is 2.8. It's that kind of one that hit, didn't it? And let's put 90 on there also. 90 is 3.6 approximately. 90 right here. 93 point. Again, we got those lines are hitting that. Alright, I'm going to draw a line through those points. Just draw my least squares regression line on here. So I figured out the equation and I put it on the scatter plot. Use your least squares regression line. Predict from the freshman GPA of a student whose interest score is 77. So I'd put a 77 in here and do the calculation. 0.074 times 77 minus 3.084. I'm actually pretty close to 77 in my table here. I've got 2.6. It's 2.614. I'll use 2.6 because that's what we're given in these. What is the correlation coefficient? Okay. I don't think we talked about that. So I'll skip it for now. But I'm just going to skip that. Maybe we'll talk about it on Monday. But as far as the test goes, since we really didn't discuss that, we won't do that. All right. Next, for 10 and 11, describe how the graph is related to y equals x squared. On this one, it is the shape of it is not changing. It is translated is translated 4 units right and 2 units up. Sorry. This one, the negative, here's the order I'm going to do it. I'm going to reflect over the x-axis. Shift or translate. Two units left. And 1 unit down. And then, I didn't talk about these coefficients that much, but if it's less than 1, you are actually compressing it. You're compressing it and it spreads out. So I'm going to write compress by a factor of 1/3. Okay, so here we go. Rewrite in this form, describe the graph. Okay, f of x equals x squared plus 6x plus something to complete the square there, minus 20 plus whatever that number is. That number is 6 over 2 squared. That's 3 squared, which is 9. I'm going to add 9 here, and I got to do the opposite. I got to subtract 9 here. Okay. This is x plus 3 squared minus 29. Okay. The vertex is at negative 3, negative 29, and it opens up. So I'm just kind of describing opens up. And has same shape as y equals x squared. As far as it is exactly the same thing, we're just moving it. Now this one, f of x equals negative 2. I'm going to go x squared plus 7 over 2x plus blank. Oh, we got a decimal here, so I'm going to use decimals here. I'm going to make this 3.5. Since we have that decimal here, I'm going to do that. Plus blank. And then I've got this 2.25 out here. So I got this, rewrote this part. I'm going to complete that square. I'm going to, it's negative 2, so I'm going to go positive 2 times whatever we put in that. And let's figure out what that is. That is 3.5 divided by 2 squared. And 3.5 divided by 2 is 1.75. 1.75 squared, raise that to the second power, 3.0625. And right here, 3.0625. Negative 2 times x plus 1.75 squared plus, I'm going to do this calculation right here, 2.25 plus 2 times 3.0625, 8.375. So what's happening here? We'll put the vertex at negative 1.75, 8.375. It opens down. And when we're at 2, that's stretching it. That's making it skinnier. It's like holding on to the vertex, grabbing it, and it thins it out. So opens down. Y equals x squared is, to have the same shape, y equals x squared is stretched by a factor of 2. If I'm between 1 and negative, or if I'm between 0 and 1, I'm compressing it. It gets wider. If I'm more than 1, I'm stretching it. All right, 14. A parabola has its vertex at 4, 1 and passes through the point 6, negative 7. Write the standard form. That's that form right there of quadratic equation of this graph. All right, so I'm going to write y equals a times x minus h squared plus k. The vertex is 4, 1, so I'll write x minus 4 squared plus 1. 6, 7 is a solution for the equation. 6, negative 7. So I'll put negative 7. I'll put a. I'll put 6 here. Plus 1 there. So I'll put the 6 in for x and the negative 7 in for y. And solve for a. That's what we're doing now. A, and that's 2 squared plus 1. Negative 7 equals a times 4 plus 1. Subtract 1, subtract 1. Got negative 8. I'm going to rewrite it more conventionally as 4a now. And I'll divide by 4, and I get negative 2 is equal to a. And that is the information I need. Y equals negative 2, now that we know a, times x minus 4 squared plus 1. Okay. One last problem. The height, y, and feet of a javelin is approximated by y equals negative 16x squared plus 79x plus 5. X is the time in seconds after the javelin is thrown. Height is y in feet. Okay. y equals, let's clear this out, negative 16 x squared plus 79x plus 5. I'll graph that. Okay. I'm going to do a couple things. I'm going to first of all turn this stat plot off. Okay, and then let's graph, and it doesn't show up. So I'm going to change the window. I'm going to go 0. How far would this javelin go? It'd go more than 100 feet. Let's go the length of a football field. Let's go 300 feet. I'm just guessing. If I need to adjust, I will. How high will it go? Let's start on the ground as 0. Let's go 100 feet. Go by tens and hit the graph there. Zero to 300. Y equals negative 16x squared plus 79x plus 5. Alright. I'm not quite understanding. Let me look at this one more time. What's going on here? It seems like it would be. Let me look at the table here. Oh, time in seconds. This is my problem. How long is it in the air? It's not in the air for 300 seconds. Okay. I need to, when we did these before, we were doing how far it would go that way. So, let me change my time. Let's go to 10. Go by ones. Alright, that's better. How high is the javelin when it is released? Alright, I think it's 5 feet. Because when it's released, that's when x is 0. Okay, and we could calculate that. What's the value when x equals 0? Okay. Value 0. Enter. Y equals 5. Okay. What is the maximum height? Okay. I'm going to raise this a little bit and go 120 feet. There, I can see the peak when I do that. So, second calc, that is a maximum point we're going for. Where's my counter here? Oops, I'm going the wrong way. Let's say we go this way. Hit enter. Left bound, right bound, enter, enter. What is the maximum height? So we want the y. And I'm going to go 102.5 feet. Approximately 102.5 feet. How long is the javelin in the air? Second calc, let's get a 0. That's when the ground is at 0. So let me come over here on the left. Hit enter. Now, I'm looking at the y's here. When I get negative, well, it looks like 5. 5, 0. But I'll just put that in for the heck of it. And this is 5. This is essentially scientific notation, very small for 0. How long is the javelin in the air? And it's 5 seconds. All right. Well, good luck to you guys.